We are beginning our second module of quantitative methods, descriptive or univariate statistics. We're not yet looking at the relationship between two or more variables. In other words, we're not looking at cause and effect yet, but we're looking simply to describe individual variables. What is the typical value of a variable, and what is the distribution of values of a particular variable. Now, this might seem quite basic, but we gain very key insight from descriptive statistics, beginning with who won an election, which party was able to get the most votes. That's a descriptive statistics question. Which country is the wealthiest? Which one has the highest GDP per capita? Which country spends the most on military equipment? These are all questions related to descriptive statistics, and they can tell us important insights about political science. The first level of measurement is categorical. So we have some variables that are categorical variables. You remember how we talked about typological hypotheses? Well, when you've got a categorical variable, you can only construct typological hypotheses with them. Their values are not rank ordered. They represent different types. So if we have the variable of religion, we would get their values representing different types of religion: Muslim, Christian, non-religious, Buddhist, Hindu, and so forth and so on. The same with ethnicity. Ethnicity is another categorical variable. Can you think of other categorical types of variables? Here is another example of a categorical level variable. This is one from the survey that I had you fill out online. Now, the largest number of people picked PTI as your party of choice. But PTI is not higher or lower than People's Party, or the Noon League, or Pakhtunkhwa Milli Awami Party. It just represents a different type of party. Hence, it's a categorical variable, party ID. The next level of measurement is the ordinal level. Ordinal variables have values that are rank ordered, but the mathematical differences between the values are not precise. So think of a 100-meter race. You're not taking the precise time of the racers, but you're simply noting which position they came in. So you could say that the number 1 was faster than number 2, but you can't say how much faster. You certainly can't say that number 2 was twice as fast as number 4. All you can say is one came in before the other. Now, the most common example of an ordinal level variable is the Likert scale in survey questions. So, for instance, if we ask, "And how far do you agree with the following statement?" There are generally 5 responses to that, from strongly agree to somewhat agree to neutral to somewhat disagree to strongly disagree. So depending on someone's answer, you can say that they agree or disagree more or less than someone else, but you can't say precisely how much more. It's simply a question of ranking. So here's an example from the class survey I had you take. To what extent do you agree with the following statement? Pakistan is a better country than most others. Now, the distribution was fairly even, and we could say that some of you agreed or disagreed more than others with the statement. But we couldn't say with a degree of mathematical precision that some of you disagreed or agreed twice as much. All we could say is that you agreed more or less than another person. So this is an ordinal level variable that's quite common in survey questions. The last level of measurement that we're going to talk about is the continuous level of measurement. Continuous variables are variables whose values are rank ordered, and the differences between the values are mathematically precise and exactly the same. So for instance, a great example would be age. The difference between a 4 and 5-year-old is exactly 1 year. And the difference between a 12 and 13-year-old is also a year. And an 8-year-old is twice as old as a 4-year-old. That is a continuous variable. Can you think of other examples? So here's an example of a continuous variable from the class survey. I tried to test your political knowledge by giving you a quiz of 10 questions about Pakistani political figures, as well as international political figures. And now we can say that those who got 10 out of 10 right got exactly one more right than those who had 9 out of 10. We can also say that those who got 5 out of 10 right got exactly half as many right as those who got 10 out of 10 right. So there is a mathematical precision to this. It's a continuous variable. Now, what is a measure of central tendency? A measure of central tendency is simply trying to find the typical or average value of a variable. And there's three key measures of central tendency that we're going to be using in this class. The first one is the mode. It's the most simplest. It's simply that value that shows up the most often. It's not much calculation you have to do here. If I ask the class, what is your religion? Whichever religion comes up the most, that's the mode. In our class, that is Muslim. The median is a measure of central tendency that tries to find the value of the middle case or middle observation. How do we calculate it? Well, we take the total number of cases or observations, add 1, and divide that by 2. So n plus 1 divided by 2. That number will give us the case whose value is the median value. For instance, we want to know what the median income in Pakistan is. So let's suppose we had the data, and let's presume that there are 200 million and one person in Pakistan. So the median person would be 200 million and 1 plus 1, that's 200 million and 2, divided by 2. That will give us 1 million and 1. So the 1 million and 1th person, if we rank ordered all people in Pakistan according to their income, the 1 million and 1th person's income would be the median income. I'm not sure what that is. I'm sure you can look it up. Lastly, we come to the mean. That is what we often simply call the average, although the technical term is the mean. How do we calculate that? I'm sure all of you have done this before. You add all the values together and divide them by the number of cases or observations. So if you want to know the mean age of students in our class, you would add up all the ages together, and then you would divide that by the number of people in class. Probably in our class it would be somewhere around 20 or 21. That would be the mean age. Now, other measures that we typically use are actually also means. So for instance, GDP per capita is the mean, measures the mean productiveness of individuals in a particular country. Some people are more productive, other people are less productive, but their production together adds up to the GDP, and the mean of that is the GDP per capita. That gives us the mean productiveness of an individual person in a particular country. So the key question is this: which measure of central tendency can we use with which level of measurement? Now, for categorical variables, you can only use the mode, because the values of categorical variables are not higher or lower than one another. They are not rank ordered. They represent different types. Now, in the example from the survey, we can see that the party that received the biggest number of votes in this class was PTI. So PTI represents the mode. It was picked more than any other party. For ordinal variables, we can use the mode and the median, because ordinal variables have ranked values, and that is required in order to calculate the median. Now, how do we do this? There was a total of 24 respondents in class, and the question was, and how far do you agree that Pakistan is a better country than most others? And the values ranged from strongly agree to strongly disagree. Now, there was 4 of you who said we strongly disagreed with this, and 6 of you who said we somewhat disagree. That's 10. and there was 3 who said neutral. Now the median person would be the 24 respondents plus 1, that's 25, divided by 2, that's 12.5. Well, we know that you cannot have half a person, so the median person would be the 12th and 13th person. So where is that 12th and 13th person located? Well, we can see the 12th and 13th person are located in the neutral category, because 10 people are in the strongly and somewhat disagree, and 11 people are in the somewhat and strongly agree. So neither the median is neither in the agree nor in the disagree categories. It is in the neutral, counting from both directions. So the median is neutral. Now, in continuous variables, we can calculate the mode, the median, but the most accurate one is the mean. And in this case, how do we calculate the mean of the political knowledge quiz score? Well, we add all quiz scores together and we divide them by the number of respondents. In this case, the average quiz score was 7.875. So that was 7.875 represents the mean of political knowledge quiz score. Now, in addition to calculating the typical value of a variable, we also want to display them graphically so as to help us understand the distribution of values in a variable, but also to help us figure out conceptually what the typical values are. Now, categorical variables can often best be displayed through pie charts or bar graphs. Pie charts in particular help us quickly see what is the mode here. And as you can see, that dark blue slice of PTI is the biggest slice. So very quickly you can figure out the mode. For ordinal variables, bar graphs seem to be best. Here we can see the distribution very quickly, and we can see sort of where is that middle value. In this case, the variable had what we would call a fairly symmetrical distribution. The middle person is located in the middle. Now, if most people had agreed or disagreed with a statement, then the distribution would be different and the median would be different. But in this case, neutral, there's about similar amount of people on the agreed and the disagreed side. So neutral was the median. I can sort of look at that without even calculating it, although you should know the calculation. For continuous variables, frequency distributions are perhaps best because many times continuous variables have such a large number of values, making bar graphs would be very unwieldy. In this case, the political knowledge quiz only had 10 values, from 0 to 10. I guess that's 11 values. But other continuous variables have almost an infinite number of values. So it's best to do a frequency distribution that we can kind of see where do most answers lie and how are these distributed. In this case, we could see that actually a fair large number of you got a lot of questions right, and a smaller number of you got questions didn't do so well on the quiz. These charts and graphs can I've fairly easily generated them from Microsoft Excel through the insert function. Now, in descriptive statistics, there is one more way how we can describe individual variables, and that's looking at the distribution. Now, in this class, we're going to stick to the very basics, and we're simply going to look at the range. And that's really only important for continuous variables. Now, how do we calculate the range? The range is essentially the range of values in a given variable. In this case, I've put two variables from the survey here. One is average monthly income, and the other one is political knowledge quiz score. Now, the range in average monthly income goes from 35 rupees a month, I wonder if that was a typo, to 1 million rupees a month. How do we calculate the range? Well, it's the highest value minus the lowest value. In this case, it would be 1 million minus 35, which is 999,965. That would be the range. And when it comes to the political knowledge quiz score, we can see that the range goes from 10 out of 10 to 3 out of 10. Nobody got less than 3 out of 10. Right. So in that case, the range would be 10 minus 3, which would be a range of 7. Now I know that in order for you to fully understand this, you need to practice and do it. So I've posted a worksheet on Moodle, and that will be the writing assignment for this week. Please complete the worksheet. The second requirement, as always, will be the discussion forum requirement. Please post one question that you have about anything that was part of this presentation. And it needs to be more than, I don't understand this, or what is a continuous variable. It needs to be a bit more specific. And then also try to answer one other person's question that has been posted on the discussion forum.